Today we're going to be talking about 2C, dividing expressions containing exponents. Mine starts on page 17. Just as a reminder, we have our laws of exponents circle that we made at the beginning of the unit. Today we are going to be talking about the quotient rule, which states that anytime you divide a base that's the same, you're going to subtract the exponents, numerator minus denominator. And then we're also going to talk about the power of a quotient rule. And what this states is that when you have two bases that are different and they're both being raised to an exponent, you distribute that exponent to both the numerator and the denominator. Let's take a look at some examples. So at the top here, I also have the rules written out again in words and descriptions. So we're going to take a look at a couple of examples. The first example, we just have one variable, y to the fourth divided by y squared. So based off of the rule, we are going to subtract the denominator, which is n, from the numerator, which is m. So we are going to write this as y to the 4 minus 2, and go ahead and simplify that to be y squared. Doesn't matter if you have more than one variable, you're going to do the exact same thing. So in this case, I'm going to have x to the 4 minus 3 times y to the 5 minus 2, and that simplifies to be x to the first, y to the third. Now, I do not need to write this as x to the first. I can actually just write this as x, y cubed. These are identical. These are the same. You can put the 1, but you don't need it. Example 3 goes along with our power of a quotient rule. Nope, I lied. It goes along with the quotient rule again. So we are going to take the 6 divided by negative 2, and we're actually going to divide the coefficients. When there's a coefficient in front, the quotient rule doesn't apply because there's no exponent on that. The quotient rule only applies to the variables with the exponent. So a to the 5 minus 3, b to the 7 minus 7. So when we simplify that, this becomes a negative 3, a squared, b to the 0 power. And let's remember that anything to the 0 power is equal to 1. And so my final solution would be that I have negative 3a squared, because this b to the 0 would actually cancel out and become a 1. And our second to last example is now going to utilize the power of a quotient rule. So we're going to write this as negative 2 squared. Any negative number being squared needs to be placed in parentheses. M to the 4 times 2 all over 8 to the m squared. Since we haven't used this yet, we want to keep it in our problem. Let's simplify our numerator. Negative 2 times negative 2 is positive 4. And then we have m to the 8th divided by 8m squared. Now we can use our quotient rule. Remember, the 4 divided by 8 is itself, separate from m to the 8 minus 2. 4 divided by 8 simplifies to be 1/2. And m to the 8 minus 2 is m to the 6th power. I can actually write this as m to the 6th over 2, or I can write it as 1/2 m to the 6th. Both of those are the same. Our last example is our power of a quotient. So this 3 is actually going to be assigned to each of the terms inside. So 2 cubed y to the 5 times 3 divided by 3 cubed y to the 2 times 3. So we have 2 cubed, 2 times 2 times 2, which is 8. And then we have y to the 15 divided by 3 times 3 times 3, which is 27. And then we have y to the 6th. Now I'm going to use my quotient rule. So I have 8 over 27, and then y to the 15 minus 6. So I'm going to look to see if I can simplify 8 over 27, and there isn't anything that goes into 8 and 27. This is divisible by 2, and this is divisible by 3, so this just stays as 8 27ths. But my y becomes 9, because 15 minus 6 is 9. So just as a recap, when you have the same base, you subtract the numerator minus the denominator exponent. If you have more than one base, you make sure that you're assigning the specific subtraction. If you have a coefficient in front, make sure you do that division separately. If you have a coefficient that is also being raised to a power, make sure that if it's negative, you put it inside of parentheses and square the whole thing. And remember, a negative times a negative is a positive. And then last but not least, if you have everything inside being raised to an exponent, you distribute that exponent to everything, numerators and denominators.